Okay, and welcome to the first video in this series. This is just going to be to get used to the working environment. I'll explain a few intricacies with Fusion 360 and get you familiar with where everything is, although you're going to have to use it repetitively to really get familiar with it. So Fusion 360, much like other 3D programs, so some of this will be, it will apply to other 3D programs, but there are some things which are specific to Fusion 360. Okay, let's start working from the bottom to the top. At the bottom we have this white bar we see here with a few arrows on the bottom left. This is actually our design history, as Fusion 360 is a parametric modeling system or parametric modeling software. However, it doesn't record the data in the same way that SolidWorks or Creo or CATIA or any of these more advanced systems do. Usually they would record it in the tree on the far left, which we'll come to in a moment, but in Fusion 360 it's going to record every feature that you create in order at the bottom. The design history is also recorded within the assembly. So if you jump into a part, that part is going to have its own design history. But then if you come back out of that part to an upper level of the assembly, it's also going to include that part's history. But if you jump into another part, all that history will be gone and it will have its own history again. So it can get a little bit messy if you're looking at the design history of the assembly. So you may want to reorder that if you would want to keep it nice and tidy so you know what's going on. We can turn off capturing the design history. That would essentially make it no longer parametric, but we'll keep that on. What you can do with this is you can use the back buttons and the play buttons to actually, I guess, kind of animate your model being made. It will start building those features and you can watch your model be built. And then we have this little bar here. So we have a few different controls which are related to the orientation or the movement of our view window or the part. But the most important thing we should pay attention to, I believe, is the display settings. So in here, starting from the top, we have visual style. So this is going to change how the model is presented to us. We have all the shortcuts here to switch between as well. Shaded is going to be our most realistic, really. Then we have shaded with hidden edges, which means that we're going to see very faint lines to represent those lines which are, behind the part that we're actually looking at, for example. Then we have only with the visible edges. So these are going to be hard lines, which you wouldn't really see in real life as hard lines like that, but it just helps you see the detail. And then of course you got wireframe, wireframe with hidden edges, and then wireframe with visible edges only. Then we have environment. So this is going to change the color of where we're working. If you're going to be creating PDFs or printing this image or copying it onto, say, like PowerPoint, for example, you may want to use something custom, maybe like a photo booth white. That's going to be the best for if you want to actually print this on paper, for example. For myself, I usually like to work in the gray room because I just like the gradient that I get with it. We have graphics presets, so you can set your performance. And then we have effects, so we can reduce the graphic effects which are running, which may help to improve your system again. And then we have object visibility, so this is another important one. Currently all of the features are showing, so if we have any planes, points, or anything that's not hidden in the tree, we're going to be able to see it. So if you want to hide any of that, so we have just a clean image of our model, we can come into this object visibility and just tick it all off. Or we can just tick off some of the things that we want to hide. For example, joint origins, we might not want to see those. We might want to hide off all the sketches if it gets a bit heavy and we have missed hiding those within the parts. I would say it's probably best practice to hide off any sketches and origins before we finish our model and continue with another model, because otherwise it will start to get messy and you'll lose track of where those parts are, especially in larger assemblies. Then of course we've got camera, which we can also change this in the view cube, but you can go between orthographic view and perspective. And then we have ground plane offset as well. And if you really want to maximize your screen, you can hide all of this stuff going into full screen mode. Here we have the graphics window. Some people may call it canvas. I think they're probably more used to things like Photoshop, but for me this is not a canvas, it's my graphics window. Top right we have a view cube. This helps us change the orientation that we're looking at our parts. For example, you have front, right, we can click on the corner to rotate our view here, or the faces. And if you want to rotate the view again 90 degrees, you can click the arrows on the top. And then I said a moment ago, we can change between orthographic and perspective. We can also see that here as well. You can also find a random view that you like, for example. It's not necessarily on any one particular point of the cube, any of the defaults. You can set that as a custom view. Over on the left, we see the parts tree. Essentially, in other programs, you're going to have the top level assembly, for example. You're going to have parts within this, and then within those parts, you're going to have the origin and then all your features. In Fusion 360, you're going to have potentially an assembly, and then your origin, and then within this part, for example, if this is just one single part, we're not going to have a list of features. We're going to have only a list of sketches that we've made within the part, and say any bodies or surfaces as kind of like as objects, but not as features. All the features will still be recorded down here in the bottom. Currently we'll see that there's a black dot here, meaning this part is activated. If we have another part, so if we want to add another part, just quickly add a component. So just as an example, this is our assembly and this is our part. If I'm modeling now, anything I do is going to be captured in this design history. And if we look here, there's a black dot next to our component, meaning that we are currently modeling in this part, in this part's design history. If we change to the tail tidy, we are going to see that history here. But anything we do within this part, we're not going to see in this part here. So we want to be very careful when we add a part. If we intend to work in this part, we should activate it first, because we may accidentally start creating features for this part when we're working in this assembly. Okay, so this is referred to as our browser, and we can hide that if you want to. Next we have our toolbar. So this is all of our features that we may want to use. We have a set of features which are used to create things, create shapes, create holes, create patterns, etc., etc. Then we have a bunch of modify features, which include like press and pull, so we can stretch features, make them longer or make them shorter. We can round edges, we can shell them, modify by combining or subtracting. We can also split the bodies and things like that, so a bunch of modify features. We have assemble, so assemble is essentially going to be adding new parts in and defining relationships with other parts or other geometry. And then ignoring configure, we come over to construct. This gives us a bunch of features which help us to construct sketches or geometry to make our parts. Then we have inspect, which gives us some measurement and some analysis tools. And then we have insert, which allows us to insert external components, for example nuts and bolts, or images that we may want to use to decorate our components. Or again, we can add other images, say onto a plane, and then use that for reference for modeling our parts. Okay, then at the top of the toolbar, we'll see that there are essentially kind of like different ribbons or different functions. So currently this is in solid. If we change the surface, we'll see everything is basically the same, except we've now got a bunch of orange features. That orange just is the surface version of most of those features we just looked at, with a few different things sprinkled in there. We're going to ignore mesh. We'll come to sheet metal. This is going to be more complicated for a beginner. We'll come to this later on down the road. And then if we come to plastics, if you compare this to solid modeling, it's basically exactly the same except for a few extra features that are more common in plastic molding, which you'll find right here. So your web and your rib. But you'll notice that if you come to solid and go to create, we have web and rib right here. and you can just click these three dots and pin them to the toolbar. So really, the plastic section is kind of unnecessary. Then we have utilities, which gives us some more inspection tools and some checking tools, as well as things for 3D printing. Okay, then on the far left of our toolbar, we'll see this design button here. This allows us to change our workspace. Now for the standard hobby license for Fusion 360, we only have access to design, render, animation, and this manufacture workspace, as well as drawing and electronics. We're only going to be focusing on design for the time being, but of course render is going to give us those nice images that you may make. Animation allows you to make, say, exploded views, or maybe you want to animate some rotating parts. A manufacturer is going to allow you to see in more detail what's going to be happening with your tooling when you're trying to make your parts. And then of course we'll come on to drawings later on as well. So at the very top we'll see the name of our part. We got redo, undo, save, and then file, which is to create new drawings. So you may want to create a drawing from the current file. And then you've got show data panel. So if you come into show data panel, you're going to see all of the parts which are in your current folder. On the hobby license, we can only have up to 10 active parts, which means we can actually turn some of our components to read-only to free up space and continue making more parts. You'll notice that I have a whole demo bike in here, so one of these parts can have a lot of components within them. So I try to make it a practice. If I have a few parts that I want to make, I'll try and make them in the same part here if they're somewhat related. Okay, so I said a moment ago over here, when I click here, I can change my workspace. Now in other programs like Creo, for example, this would not be called workspace. In my experience, the workspace would be like our file directory that would be downloading the cloud stored files onto our own PC or our own workspace essentially. Then we have our controls. So if we click in the middle mouse button and drag it along, we can see that the graphics window is moving around. It's actually panning, and we can tell that because over here we have a view cube. If we pan around, we can see that the cube isn't moving because we're not changing our point of reference, where we're viewing from. We're just moving the part. Now if you hold shift, click in the middle mouse and then move around, you see we now have this orbit looking icon on the middle of our screen, and we can see that the view cube is rotating around. Now if you want to zoom in and out, obviously we're going to be scrolling in and out, and if you don't like that, you can hold shift and control, middle click in and drag back and forward. And then of course if you don't like that, let's activate the origin so it's easy to see. You can click on the view cube itself. If you want to rotate the view, if you want to look at it from the corner or the edges, you can always change it like this. Now there's a little arrow here. From here you can change it from orthographic to perspective. Perspective is like if you look at something from a distance, something close to you is going to look bigger. It's going to put it into that kind of perspective. But usually when we're doing modeling, you want it in an orthographic view. Now in Fusion 360 as default, your origin is hidden. So once you click this arrow here, I want you to open up your origin so you can see it. So this is our origin point or datum point, our three planes made by our three axes. Okay, so now we've activated the origin, I want you to get used to sketching. So if we create a sketch and we select any of these planes, what you'll find is we have this grid. And if we select any of these sketch features, you'll feel that it's snapping to all these points. And when you're getting a bit more accurate with things, you maybe don't want this snapping turned on. So you can turn that off over here in the sketch palette. Now we're free to sketch as we want. Other than that, I don't usually turn things off. Sometimes you might want to hide the constraints when you're working with bigger assemblies. They start to get in the way. Sorry, when you're working with bigger sketches. And then eventually when you get to the point when you start using 3D sketches, you'll have to switch this on. For now, this is just going to be left over here. So let's say we just draw a straight line. We select the point here and we drag it out here. We'll see a couple of things going on. We have the length of that line and an angular relationship, which is automatically being generated relative to our x-axis. As I move this around and I make it 90 degrees, it's automatically going to try and constrain this with a vertical constraint. Constraint just means control. It's going to put a lock on this geometry. So now this is locked to vertical after I've left clicked again. And if I want to end this, I can just click the tick there. I usually just press escape. I find it's a bit easier than trying to move the mouse to a button. Or of course you can right click and just click OK as well. Now that we have this vertical constraint, this part cannot be changed from this vertical orientation unless we select that constraint and delete it. Then we can move it around again. So when we mention the constraints, what you see is at the top here we have our create. So we create that line and we got some different shapes we can create. We can modify these sketches. So it's very similar to our solid and surface tabs here. Then we have constraints. This is something new. So vertical and horizontal, as you said, this is going to apply a lock either horizontal or vertical depending on which one it's closest to. So right now, if I click this, it's going to be a horizontal constraint. Just undo that. Then we have coincident, which just means that if I draw these two lines, these are not connected. If I move that over here, this is going to imply a coincident joint between them, which means that they're now locked together. And that looks like this. So if I want to delete that, select that and delete. Or you can select the coincident feature at the top here and then select which one you don't want to move and then which one you want to move. The only problem with this is because it's not constrained anywhere else, the whole sketch is going to move. Okay, and the next one is the tangent constraint. So this one is essentially just going to set a nice relationship between a straight edge and a curve, so that the straight edge doesn't protrude, it just comes in line with that edge, so you can trim it back really nicely. We also have an equals, so these two edges are different lengths right now, but if we want, we can say equals. Now these are going to be the same length. We can also say parallel. And then we can put another line in here, and now we can say perpendicular. Notice with this part that we can move it around currently as freely as we like, and we can stretch it. But it's always going to be perpendicular to this one. Now if we apply a fix, what this is going to do is it's going to lock it in this plane. We can't move it per se, but we can stretch and shrink it. If you click it again, we can unfix. We have midpoint. So in terms of a straight edge, this is going to give us our midpoint if we have another line to connect it to. Let's say this one, we have it perpendicular now, and we want to put a coincident constraint between this point and the midpoint. We can say this point to here, and that's going to give us our midpoint of this line. The next one is concentric. Concentricity means essentially this. This circle is in the middle of this circle. This is an important thing to consider later on. I'll go over that when we talk about GD and T. We have collinear. This means that it's in line essentially. So we put that relationship there. We can control these edges together relative to this point, for example. And now they're both going to be related in this way. Symmetry, again, I think this one's fairly obvious. Let's just put a sketch here first. And then we will put two circles. Now different sizes either side of this line. Now if you put a symmetry constraint between this one, and then select our line of symmetry, it moves the center point of each circle to be symmetrical, although the sizes are not. If you want that to be the same, you need to use the equals. And then you want to define a dimension of the size of that circle, for example. One last thing, when you are creating your sketches, if you right click, we can come into here, we can see normal and centerline, and switching something to a centerline or to construction geometry. Those are going to be, I use construction geometry a lot when I'm creating sketches, but if you're using something that's going to be like a revolve, like a bolt or a cap, then the centerline feature would be ideal. Okay, so I think that's going to cover it for part 1. Part 2, we'll start creating our construction geometry, setting us up ready to start modeling our tail tidy. Okay, thank you very much, and I'll see you on the next one.